Hi Year 11. This is the next video for 2B Scientific Notation in case you're having difficulties. Can you please make sure you have watched all those Maths Online lessons? That's 8702, 8703, 8705 using a calculator. Now, if that one doesn't pertain to your calculator, I've put some extra how to use your calculators at the bottom of the classwork page for Thursday. There's one called Change Numbers to Standard Form. That's for a Casio or Abacus if you have it. And then there's another one for scientific notation on the Sharp EL531 calculator. So try and find whichever calculator you have, try and find one of those and just watch and see what they do, because that will help you use your calculator better. And then the final Maths Online one is 8754. And that's operating with numbers in standard form. So that means doing timesing and dividing and stuff like that. So you really need to watch all of those before you even get to me. That would be great. So scientific notation, just in case you're not sure and you can't remember, it's basically another way of writing very large and very small numbers. So it's a way of abbreviating them, okay? If you have a huge number like 5,300,000 blah, 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 okay, you need to be able to write that in a shorter way, because numbers, let's face it, get a lot bigger than that. They can get to 10 or more digits. So you need to know a way of shortening those, because you can't write those, 100 digits in a test, can you? No, of course not. All right, so here we go. Here's example 2B1. I'm going to do it without a calculator first so that you know how to do it in your head. State whether the following numbers are expressed in scientific notation. So the first thing you need to know is the first part. So this part, I'll get the pen working, okay, so the pen is now working. This part here has to be between 1 and 10, okay? It can't be 0 point something, it must be 1 point something, all the way up to 9.9. It can't be 10 either. So it has to be between, so not including, between 1 and 10. That doesn't look like between, but anyway. So that's the first thing. The second thing, pardon me, sorry about that, is that this number has to be 10 to the power of something. Okay, so let's have a look at some of these numbers. I will just get rid of this so it's not in the way. Okay, so let's have a look at these examples from your textbook. So first of all, we have 5.3 times 10 to the power of 7. It says state whether the following numbers are expressed in scientific notation. Well, the first one is a yes. Here it is there. And yes, it is correct. The first number is between 1 and 10. So it's got a counting number, then the full stop, and then all the other counting numbers after it. And here we have a number that is 10 to the power of something. So that is a yes. So let's have a look at B now. All right, have a look at this number. Is it between 1 and 10? No, it's not. It needs to be 7 point something. So therefore, it's a no. So that's correct down there. That is definitely not in scientific notation. Don't need to look at the next bit, but the next bit is correct, isn't it? The 10 to the power of 5. All right, question B. Is this between 1 and 10? Yes, it is. Okay, so it's a counting number, then the dot, and then a 9. However, this one here is not 10 to the power of something, is it? So it must be 10 to the power of something. So that's why that one is a no. And the last one over here, 3 times 10 to the power of negative 4. Is this number between 1 and 10? Yes, it is. They don't have to have a dot, okay? And is this number 10 to the power of something? In fact, it is, okay, even though it's to the negative 4, that's fine, okay? So here, yes, our answer is a big fat yes. All right, and the last one, all right, is this one to scientific notation? Well, it's definitely a no. It's not between 1 and 10, is it? And there's no 10 to the power of anything at the end, is there? So this one most definitely is a big fat no, okay? So they're the rules for how to write things in scientific notation. Let's try some of these questions down here. Let's see how you go. You may pause at any time, okay? So please do that if that helps. Question 1 says, use the flow diagram below to determine whether the given numbers are expressed in scientific notation. Okay, so let's look at this one here. Follow the same steps. Is the first number between 1 and 10? Yes, it is. So is the given number expressed as a product of two numbers? Okay, so is there one number, then a times, and then another number? So yes, we are correct. So far that is correct. Still looking at A. Is the first number between 1 and 10? Yes, it is. It's 2.91. That's between 1 and 10. Yes, so we're following down. Is the second number expressed as a power of 10? Yes, it is. You can have negatives. So that means, yes, our answer is definitely written in scientific notation. All right, so 1A is a big fat yes. Yay, yay for yes. I'll get rid of these. Let's try the next one. Question 1B. Oops, sorry about that. Let's follow the next one. This one here. Is it expressed as a product of two numbers? Yes, so that's okay. We can give that a tick. Is the first number between 1 and 10? No, it's not. So therefore, this one's a big fat no, it's not in scientific notation. All right, let's try the next one. All right, the next one. Let's follow it again. Is the given number expressed as a product? Yes, it is. There's a number times by another number. Is the first number between 1 and 10? Yep, it's 3.8. That's between 1 and 10. The next one, is the second number expressed as a power of 10? No, it's not. So this is not to a power of 10. So our answer is no for that one. And question D, last but not least, 3 to the power of 26. Let's do the first one. Is the given number expressed as a product of two numbers? No, it's not even finishing. It's not doing that first one, is it? So that's a no. All right, let's move on. So question 3, complete the following to write each number in scientific notation. 243,000. Position the decimal point between the first two digits. So the first two digits are the 2 and the 4. Now what you need to know is you keep all of the counting numbers. So that's any numbers. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. So no zeros unless they're between counting numbers. So that's the first thing I did. I kept the 2, the 4 and the 3. My number has to be between 1 and 10. So I do 2 point and then 4, 3. The number of places to the original position of the decimal point is something to the something. Oh, that's good, isn't it? All right, so let's have a look. Number of places to the original position. So the original position in a whole number, the decimal point is at the end. All right, so we are moving it from this end to in between the 2 and the 4. So we have moved it. Let's jump 1, 2, 3, 4, 5 spaces, and we have gone to the left. So position. The original position is, I guess, 5 to the left. I'm not sure if I'm doing this around the right way. I'll have to check this in a minute. Number of places to the original. I think maybe we were supposed to go the other way. I think I was supposed to start in between the 2 and the 4. So maybe this one might have to actually be for right. I'm going fast. Okay, so that means if we have, that's good, if we have 5 places to the right, that means my index is going to be a +5. So now here's where my answer will go. I'm just going to make it big because I'm not going to fit it there. So my 2.43 goes here, and my 5 won't fit in that box, is going to go there. So instead of that box, I'll put a 5 there. So there's my final answer. So notice, if you have a big whole number, your index should be positive, just so you know that, okay? Whole number equals a positive index. All right, so now we've got B, we have decimal 0.000586. Position the decimal point between the first two digits. All right, so the first two digits are 5 and 8. So I'll make it bigger so it's not too messy. 5.8 is what my answer should be. So now it says the number of places, sorry about that. Oh, it keeps moving, my bad. The number of places to the original position of the decimal point. So the original position of the decimal point was here at the beginning. And I'm now moving it to in between the 5 and the 8, aren't I? Oh, I forgot the 6. Sorry about that. Put the 6 on there. So now I'm going to go 1, 2, 3, 4. I have moved it 4 places. And this time I have gone to the right. Now that's the same as before, isn't it? The number of places I've gone the wrong way again, haven't I? Sorry, just smack me, will you? So I've actually started at the dot in between the 5 and the 8, and I've jumped back towards the left. So the number of places to the original position was 4, and to the original position, to end up at the original position, I have moved to the left. So that means I'm going to do a -4. So this time I'm going to have 5. I'll make it bigger so it fits nicely. So 5.86 goes here, and -4 goes in here. So I want you to take notice. Index is negative when you have it's going to run out in a minute, a decimal, okay? So just be aware of that. So the index is negative when you start off with a decimal in your question, okay? Just so you know. All right, example 2B2. Let's go through this together. Writing numbers in scientific notation. All right, so we've kind of already been doing that. Let's try it again. So the first one is 138,000. Okay, so we need to have a number between 1 and 10. So that means I'm going to write my first counting number down, whatever it is, and then put a dot, and then all the other counting numbers not including 0. I need to then have a times 10. Okay, I've started off with a whole number, a big whole number, so I know straight away my index will be positive. Now remember, you don't have to write the positive in. I'm just doing that so you get to know it. So starting from, doesn't really matter what end you start from, I'll just follow what they did. Oh, goodness me. Keep doing that. 2 fingers miss. If they started from the decimal point at the end, they move to the right. So if you start from the end and you move to the right, 1, 2, 3, 4, 5, then we write a 5 in our index position. Okay, let's double check. 1.38 times 10 to the power of 5, that's what they got. All right, let's try this one now. So let's do the same thing. You have 3 counting numbers this time. Put a 4, a dot, an 8, and a 6. Multiplied by 10 to the power of. Now notice we are starting as a decimal. So that straight away tells me it's going to be a negative. Okay, so this time I'm moving from this end to in between the 4 and the 8. Notice I have jumped 1, 2, 3, 4 times. So I'm going to put a -4 in my index position. Okay, so that gives me the correct answer. If you notice down here, that's what it is there. Okay. All right, let's have a look at 2B3 example, changing from scientific notation to an ordinary number. All right, so here we go. So what I like to do is I like to write the decimal out because I'm going to jump one way or the other. Okay, now if this is a positive, that's telling me that my answer is going to be a big numeral. Okay, it's not going to be a decimal. So that means I'm actually going to jump 7 places that way. That way is right. Okay, so starting from here, I'm going to jump. I'll make it a different color so you can see it better. 1, 2, 3, 4, 5, 6, 7. Okay, now what I need to do now is all of those jumps that don't have a number under it, I need to put zeros there. Okay, so we don't have the dot anymore, we disregard the dot, and hopefully you'll notice we should have 1, 2, 3, 4, 5 zeros at the end. And if you have a look here, 1, 2, 3, 4, 5 zeros at the end. So our answer is 48,300,000. Let's try this one here. We need to change this one to an ordinary number. Now you need to know, I'll make that a bit weaker, that if it's a negative, that means I'm going to get a decimal as my answer. So that means I'm going to have to jump my dot this way this time. So to do that, what I do is I put my 9.2, but I write it, you'll notice I write it further over to the right because I'm actually going to jump it this way. All right, now it's telling me to jump it 6 places, so that's what I'm going to do. So here we go. I'll do it in green just so it's different. Here we go. 1, 2, 3, 4, 5, 6. Now that's where my decimal point goes. I'll do it in red. Now remember, every decimal starts with a 0 point, doesn't it? Now you have to, in all of these little jumps here, they're a bit yucky, you've got to put zeros in all of those. So you should notice that after the dot I have 1, 2, 3, 4, 5 zeros. And then the 9, 2, let's see. 1, 2, 3, 4, 5 zeros, and then the 9, 2. So there you go. That's how you do these. All right, are we nearly finished? Oh, for God's sake, I did it again. All right, here we go. Let's try question 6. Oh no, there's some more. Question 6 says, complete the statements to write each of these numbers as an ordinary number. So 5.48 times 10 to the power of 6. So we need to move the decimal point 6 places. Oh, that's a good writing, isn't it? Didn't work at all. 6 places. Sorry, my pen doesn't work unless I make it really big. And I have to move it this time. Remember, it's a positive number, so I'm going to get a whole number answer. So I have to move it to the right. So I'm just going to write R for right. Okay? So A will be 5, make it bigger, 0.48, 1, 2, 3, 4, 5, 6. So I'm going to put a 0 in each of those jumps. No more dot there. So my answer is 548 with 4 zeros after it. There's my answer for A. All right, my answer for B. Well, if you have a look at B, this time it's a negative. So I have to move it that way to get my decimal. That's a 5 there. So I'm going to move the decimal point 5 places this time, but I'm going to move it to the left. So let's have a go. What is it again? 3.09. So I'll move it over here, 3.09, and I'm going to jump it 5 to the left. 1, 2, 3, 4, 5. Oh, goodness me, that's pretty ugly, isn't it? Okay, put zeros underneath all those humps. Disregard that dot. I'm going to rewrite it so it looks neater. It needs to be a 0 point, and then now 4 zeros, and then the 3, and then the 0, and then the 9. Make sure you take out that decimal point. Okay, let's keep going before we run out of juice. All right, example 2B4. Okay, so this you need to do on your calculator. So you might have to watch the calculator thingies. This one's pretty much set for the Casios, I think, close to. So on the Sharp, you need to use EXP. So what you need to do is your calculator does all of this for you. So all you really have to press is 3.5, EXP, and then, so for this one here, 3.5, you have to press EXP, and then what is that? A 7. And then a 7. Okay, if you've got the Casio, I believe it's a times 10 to the power of something button. I can't remember if it's an X or a box. All right, so on the Casio, that EXP or times 10 to the power of button, it presses the times for you, it puts the 10 in for you, and it presses the, to the power of. So you don't have to press any other buttons. If you press any other buttons, you might find you'll get different answers. So just watch out for that. So that's the beauty of the EXP or the times 10 to the power of button. It does all of this bit for you. Okay, if you want, you don't even need the brackets. So for A, I'd be pressing that, then I will press the times in between, and then I would press the 2.4, then I would press just the EXP or the times 10 to the power of box or X, and then just the index 9, no to the power of, no nothing, and then equals. That should be all you need to press, and it should give you the correct answer. Okay, this one here in question C, you may need to put that in brackets. Otherwise, you're going to have to press square root first. Doesn't like writing when it's tiny. Anyway, play around with it. Okay, check to see if you get the answers that they do down here. And basically keep playing with the EXP button. Remember, you don't have to press the times 10 to the power of. The EXP button does it all for you. All right, and now try the sheet. Now, don't have to do these ones. Can you double check and see what the questions were written on the classwork page? Thanks, guys. Bye.